The next slide, route tables and using route tables in Amazon VPC. So we'll see what are the things that we can discuss here. Amazon's definition is of a route table consists of set of rules and call route. So okay, this is the route table. So it will be again defined with IP addresses, and you'll typically call it as a systems only, like networking systems only. What you do here is each subnet in your VPC must be associated with a route table. So you have the separate subnets in the environment, network environment, right? So it will be connected to this route table, and the subnet can only be associated with only one route table at a time. So let's say I have a subnet which is in the one availability zone. That subnet can talk to only one route table. It cannot have the multiple route tables associated. It can have only one,
Mm-hmm.
but you can associate multiple subnets in the same route table. That is by uh, but how you can map it here is like through the custom configuration that you can map multiple subnets with the same route table. Let's say subnet 1 and subnet 2 I have, and those two subnets can route to this, but subnet 1 cannot connect to two route tables. Is that clear?
Yes.
Okay, yeah, that is a difference. Okay, so coming to the network gateway diagram, so let's understand what are the components here we have and how do we differentiate it. So every VPC has a default route table, right? So this is a one VPC, and it's a route table. So here this is the router, and these are the two route tables for this VPC, and for this VPC this is another route table. So here you have the custom and all this information, the target and the IP addresses, and there is an internet gateway for this, and this is a local system. So when you're connecting to this, you can have the multiple set of route tables, but every VPC system should be having one route table. Uh, it's all because as we have seen in the previous slide, right? You can have the one VPC can have the one route table, but this route table cannot have the two VPC connected to it. It's only one which should be connecting to route table. But this VPC can go and connect to the another route table also if we can customize it. But a route table can have only one VPC. Hello.
Yes.
Looks like I reconnected to the session again, so it showed that I was reconnecting. So I thought to check whether I'm audible or not. Yeah, thank you, Patrick. Okay, the next question is which of the following is not true about route tables? So can we take this question?
Okay. Which of the following is not true about route tables? Um, I will. I might
Hello.
I think it's A or C, but I will be.
Yeah, it's a C.
Hello?
It's a direct. Yes, Patrick. It looks like your voice was disconnected in between. So what I'm saying, it's a direct answer. It's a which is a NAT to to enable this instance to your private subnet. So with the other AWS services also you can enable it, but it prevents internet from initiating connections within the instance. So you have this internet here, and you have the from subnet, and you have from subnet, which is you have only the NAT device, which will enable your instances to the private subnet to the connect. I mean to connect to the internet services or any other AWS services which is there in your private subnet. But if you do not have this like a network address translation which is attached to your private subnet, you'll not be in a position to access the internet to the private subnet. It'll prevent that internet connection within the private subnet. So this NAT device will play a key role in getting the internet from the subnet to the private subnet. Okay, so coming to the next one, so which is a little bit elaborated way to see the end-to-end flow. So here these are the different route tables, the custom route table and the main route table. Here you have the internet here, and within the AWS cloud you have the internet gateway and the router, which is again connecting to your private subnet. But when it comes to the NAT device, which is your private subnet, and you would be connecting to that particular private subnet using the NAT device from the internet, right? So internet, it will come to the gateway router, and then it will go to your NAT device, which is there in your private subnet, right? But whereas if it is a private subnet within the availability zone, and it is which is the normal, the main route table, but this is a private route table which will be getting the internet connectivity from the NAT device to the private cloud. Okay, so coming to the next slide here, NAT gateways versus a NAT device. So we'll understand what is the difference in these two. So in the AWS cloud, you'll have the NAT gateways and NAT instances. Uh, okay, the NAT gateways, the gateways must be launched into a public subnet. So if you have somewhere the public network, which is not the private subnet, right? So in case of public subnet only, you'll have the NAT gateways, which will be connecting to your private subnet using the private subnet IP address information. This is where we would be using the NAT gateway. Coming to the demonstration of NAT gateways, even I think I do not have this service in my cloud account. So I'll go to the next slide, knowledge check. So we'll go to the knowledge check and see, probably it must be the direct answer. Why does AWS recommend using a NAT gateway? Patrick?
Mm,
Yeah.
it manage the device services. It provides better availability and better bandwidth. Um, I will not use all of the above. Is correct.
Yeah, that's a correct answer. So in the NAT gateways, it is, we can easily manage the NAT gateway. So if you want to have the cloud available to that your subnet, you can have this NAT gateway. So it's a very easily, manage this service, and it provides availability and bandwidth within bandwidth than NAT instances. So NAT gateway is better than NAT instances, and it provides redundancy in the user where it is created. So you can take answer as a D for this particular question. So D is the right answer. Okay, coming to the next question here. What does NAT gateway requires to function properly? So yeah.
Um, I I would go with, it's between B and D, but I'll go with D.
Okay, yeah. So B is the right answer here. Why? Because we discussed about in the public subnet only we would be using the NAT gateways, and and also have elastic IP address. So the answer
Oh,
here
okay,
would be B. Yeah,
okay.
yeah. B is the right answer. Okay, security groups. So we'll discuss about what are the security groups available in VPC. So this is specific to VPC. We are talking about from the couple of slides onwards. So the security groups which are available in the VPC. So the which is again a virtual firewall that controls the traffic for one or more instances. You can add rules which I mean you can there is a customized option that you can add rules what kind of rules that you wanted to create it for specific IP addresses. You can write a rule to allow that request coming to that particular server. So it's all customized. You can even add the rules based on the rules how it has to navigate to the private cloud. So those things that you can clearly mention in the rule so that it will take care when that particular request is going through that particular IP address. Okay, security diagram, security group diagram. Yeah. Okay. Okay, so this is a similar setup diagram which we are seeing, but only the difference here would be like this is a private subnet and this is also a private subnet available in this particular availability zone. But there is a NAT device which is attached to this private subnet to get this information. What we can and it cannot access our instances that reside in the VPC. So in the VPC, if you do not have the NAT device, right, you will not be in a position to get that information within the private subnet. So there are security groups that we have been given to these private subnets. Okay, coming to the next slide, security groups for web servers. So here you have HTTP servers and HTTPS servers, like the protocols, I would say. Like you'll have the port range starting from 80, and here the for HTTPS port range is starting from 443. And all these things would be, you would be adding into your security groups, and this is the source information. These are the web servers, like how it receives any kind of a traffic from the like the normal internet on HTTP and HTTP ports, HTTPS ports. So this is how the security groups for web servers. Similarly, the security groups for the database is what you can have it, which is hosted within the VPC. So like you can have a MS SQL server or RDP, but the port range is also given here, which is 1433 and 3389. We can, I think these things we no need to remember, but when we are doing something or enabling something within the VPC, you can have this as a reference document and go and configure these kind of a service within the VPC. Right. So these are the security groups for the database servers. And coming to the next slide here, which is a security group rules. By default, you'll have the security groups allowed on onboard traffic, and you'll have the security groups for stateful. All the security groups are stateful. You'll not have any stateless in this. Because it is very much required to have the stateful information when we are having connecting to the security groups. Rules any always permissions. 1 second, yeah. Okay, you can modify the rules. So as I mentioned, like you can modify the rules based on the kind of information that you wanted, or the kind of uh, servers that you wanted to enable while hitting that server, right? So you can customize your rules. You can write your own rules